we are going to do a FET on density. And part of this is just to enjoy, and you're going to get this thing, and it's going to tell you not to do it, but you're going to do it. All right. Sort of play around with wood or ice or brick. So you really should play with these things and get a feeling for it. One thing you should notice, so this is 100 liters of water. And if I put this brick in here, it goes up 5 liters. So therefore, the size of this brick had to be 5 liters, because without the brick, it's 100 liters. With the brick, it's 105. If I half submerge it, then it's half of that, right? So 5, 2.5, and 0. Anyway, that's a nice way to do that, and we'll do that in lab. But I will expect you to know that. But the fact of the matter is this brick sinks. And even if I try to reduce the mass, the brick stays sunk because it's losing volume as well. So its density, its mass to volume ratio is staying the same. All right. So if we had everything that was the same mass like these are all 5 kilograms, but this 5 kilograms likes to float because it doesn't take a lot of space. And this 5 kilograms likes to sink, because it doesn't take a lot of space. This does take a lot of space. This doesn't. They're the same mass, so therefore this is more dense. All right. So when we're playing with this, another fun thing you can do is you can kind of throw these up, and then they come back down. And if you throw it on an angle, it won't come back down. Anyway, if that ever happens, just hit reset. The thing you're going to need to do in class is make sure you know how to figure out all these mystery boxes, which is figuring out how much they weigh. So this is 3.53 kilograms, and then how much volume they take. So it takes up 1 liter. It's 3.53. So the density, oops, not going to let me walk on that. The density is the mass divided by the volume. So in that case, it is 3.53 divided by 1. So that would be 3.53 divided by 1, which is therefore 3.53. That's kilograms per liter. And if you look at the thing provided for you here, the table, 3.53, that's diamonds. So this stuff is made out of diamond. That's how it has that density. All right, kilograms per liter. Yeah. So mass will be given in the units of grams or kilograms. You need to know this. Anytime you see grams or kilograms, they're talking mass. Volume will be either milliliters, liters, or centimeters cubed. So these are really, in my opinion, pretty easy equations you don't even need to memorize them, because often in multiple choice stuff, I'll say, what is the density? I'll say, what is the density? And the choices will be in grams per milliliter. And that's telling you, take the grams divided by the milliliters. Okay, that's what that's telling you. So that's what you should do. This little triangle seems to help people, where the density is equal to the mass over the volume is equal to the mass over the density, and the mass is equal to density times volume. So these two are multiplied, and then these are like the divided by sign, like mass over density kind of thing. All right, another way to remember it is here, where density equals a heart with a line through it. So the M of the heart is there, and the volume is on the bottom. So another way to remember it. This is all simple algebra, so it should be easy. Let's take a look at a sample problem here. So you have 35 grams of lead, and it has a density of 14 grams per centimeters cubed. How much volume does it take up? So we're looking for, we have grams, and we have grams per centimeters cubed. So the only thing we don't have is the centimeters cubed. So we're going to start with that 35 grams, and we're going to multiply it so that this 14 grams is on the bottom, and that centimeters cubed is on the top. And the way that's going to work is these grams are going to cancel, and that's going to give you 35 times 1 divided by 14, the density of what you're looking at. And that is, because I can't do that in my head, 35 divided by 14 is 2.5 centimeters cubed. So that's the volume of that. You could have also used any of these equations where we have density is mass divided by volume, right? Or what we did here was we took the mass and divided it by density, right? So mass divided by density equals that, which is what we did. Okay, gold has a density of 19.3 grams per centimeters cubed. A cube of gold measures 2 centimeters on each side. What's the volume of the cube? So another thing we need to learn this year is where this centimeter cubed and milliliter thing got associated. And if you have a cube and each side is 2 centimeters, then the volume of the whole thing, how much space the whole thing takes, is the area of this square, 2 times 2. So that's this square down here, times the height, which is also 2. So 2 times 2 times 2. So 2 centimeters times 2 centimeters times 2 centimeters equals 2 times 2 times 2 is 4, is 8. And then centimeters times centimeters times centimeters is centimeters cubed. So that's why volume is measured in centimeters cubed. And we'll do something like that in class. So the volume is 8 centimeters cubed. And the mass of the cube would therefore be, we're looking for the mass. If you need an equation, the mass is equal to density times volume. If you don't want to memorize that equation, this is telling you 19.3 grams per centimeter cubed. So 19.3 grams per centimeter cubed. It should make sense that if we multiply that by centimeters cubed, they will cancel. So if we multiply that by 8 centimeters cubed, the centimeters cubed will cancel. The only thing left is grams, which is the units we're looking for. 8 times 19.3 is whatever that is. 8 times 19.3 is 154.4 grams. Okay, hopefully that works. Moving on a little bit further, here are some common densities. So this is a property of the substance you're looking at. It's called intensive, I believe, because it deals with the, doesn't matter how much you have, it's the same density. So butter, no matter whether you have a pat or a gallon of it, it'll have this density. Ice, whether it's shaved ice or an iceberg, has that density, right? So it doesn't matter how much you have, these densities are going to be held true. So they're nice little properties of substances. And because of that, we can find out how to determine a substance based on its density. So let's do that right now. I know I'm boring you right now, but let's do it anyway. So if we graph data, we can find out some densities. Here's a piece of data paper or graph paper. Our volume goes from 0 to 50, all right? So our volume goes from 0 to 50. So volume's down here, and we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14 of these. So every 2 can be a jump in volume. So this can be 10, and then a jump of 2 could be 20, and a jump of 2 can be 30, jump of 2 can be 40, and a jump of 2 can be 50. So our volume works fine. Now our masses, let's look where our masses range from. Our mass ranges from 0, and the highest one looks like 60. So going on this axis, we got to go from 0 to 60, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have more than 12. So we can again do 2. So this is 10 grams, and this is 20 grams, 30 grams, skip 1, 40 grams, skip 1, 50 grams, skip 1, 60 grams. All right, so that hopefully makes sense to you all. We got this on here. Now, what we're going to do is graph like object A. So object A goes 2, 4, 6, 8, 10. So let's change our color. Oh no. Let's see if that works. Okay, so let's change our color. We'll go red. So 10, it was 2, 4, 6, 8. So at 0, it was 0, right? At 10, it was 2. So if this is 5, 2 is a little less than halfway up there. Let's get out of that. Okay. At 20, it was 4, so still not up to 5. All right. At 30, it was 6, so a little bit above 5. At, why is this not doing, all right, this was 4, and this was 2. Ballpark, just, okay. All right. Lovely. All right. 40, it was 8, so a little bit below 10. And at 50, it was 10. So here's our first line. Okay, that was that first material. Then if we go to the second material, it goes 12, 24, 36, 48. So it's going up by jumps of 12. So again, we're going to change the color, change it to blue. So it starts at 0. And then at 10, it's 12. So a little bit above 10. At 20, it's 24. So a little bit below 25. At 30, it's 36. So a little bit above 35. At 40, it's 48. So a little bit below 50. And at 50, it is 60. So that's the highest one. So here's that second line. All right. And then the third one goes 8, 16. So it goes in jumps of 8. So this is B. And then that was A. This is A. Oops, that's not red. Oh, it's A now. All right. And then let's go green. So this one's going by jumps of 8. So again, it's 0, 0. And then at 10, it's 8. So it's a little bit below 10. And at 20, it's 16. So it's a little bit above 15. And at 30, it's 18. So it's a little, wait, 30 times 8 is 240. Sorry, 240. So it's about there. 40 times 8 is 320. So it's a little bit above 30. And 50 times 8 is 40. So it's there. So then there's the green line for substance C. So we have A, B, and C, and that's still going to annoy me about A. All right. So what is the density of each object? So now we can figure out the density two ways. You remember that the slope of a line is equal to the change in y over change in x. And if you look at what our fraction or our axes are labeled, the change in y is the change in grams, and the change in x is the change in milliliters. And grams over milliliters, that's density. So the slope of these lines are densities. So since this has a low slope, that's a lower density. Since this has a more extreme slope, that's a higher density. Anyway, you could also just plug in anything. So 10, grams is 2, the volume is 10, so 2 divided by 10 for A will give you, so A is 0.2 grams per milliliter, right? Because that's just what that is, 2 divided by 10. 2 divided by 10. All right. For B, this is too long a video, but you'll deal. I'll get better. All right, B is here, so you can choose any point again. When volume is 30, so the bottom is 30 because density is grams per. The mass is 36, it looks like. So 36 divided by 30, the density of that is 36 divided by 30 is 1.2. That's 1.2 grams per milliliter. And then object C, which is the green one. So the green one has a density, so we can use 40 as our mass. So 40 grams divided by 50 milliliters. So that's what density is equal to mass over milliliters, mass over volume. So grams, 40 divided by 50 is 0.8 grams per milliliter. So which is the least? The least is the A because that has the lowest slope, and that's 0.2. Which is the most? The most is B, and that's 1.2. That's figured out by numbers, right? Water has a density of 1 gram of mil. So if we put water in here, and let's make that dark blue, I guess. So I already took light blue. So water has a density of 1. So 10 is 10, and 20 is 20, and 30 is 30. You will be expected to know this at all times. Water has a density of 1. You will prove it to yourself in lab. So here's what the line for water is. So anything below the water will float, right? Because it has a lower density than water. So water is 1.0 grams per mil. So this would float on water, and this would float on water, and anything above it would sink. So B having 1.2, that's greater than water, so that would sink. So this sinks, and these float. All right. That's just another density question, which we can try out in class. I'm sure I've bored you plenty now. We'll discard all this. I hope that's helpful to you. And if it's not, please come see me and I'll happily talk to you about it.